Good day everyone. Today, we're going to teach you how to factor completely polynomials involving perfect square trinomial. At the end of the lesson, you will be able to first recall square of binomials, square root of a number or expression, and perfect square number or expressions. Second, describe perfect square trinomials. Lastly, is to factor completely polynomials involving perfect square trinomials. Before we start with factoring, let's have a review of getting the square of a binomial. We'll be using the techniques on special product since these are squares of binomials. Following the pattern: 1. Square of the first term. 2. Square the second term. 3. Get twice the product of the first and the second term. To start with, we have the following items. Let's try to get the products of these polynomials. For number 1, square of x is x squared. Square of 3 is 9. Twice of the product of 3 and x is 6x. So, the final answer is x squared plus 6x plus 9. Number 2. Square of x is x squared. Square of negative 7 is 49. Twice of the product of x and negative 7 is negative 14x. So, the final answer is x squared minus 14x plus 49. Number 3. Square of 3x is 9x squared. Square of negative 4 is 16. Twice of the product of 3x and negative 4 is negative 24x. So the final answer is 9x squared minus 24x plus 16. What we actually had as the final answers in the examples are called perfect square trinomials. That means getting the square of a binomial equals to a perfect square trinomial, and getting the factors of a perfect square trinomial as reverse process of one another. For the important concepts in this lesson, we have first, perfect square trinomial. Again, it is a trinomial that is a result of getting the square of a binomial. In identifying if a trinomial is a perfect square trinomial, it is important to recall the difference between a square root and a square of a number or expression. We have, for a square of a number, this is the result of getting the product of a number or expression multiplied by itself. Example, square of 2x, that is 4x squared. On the other hand, we have square root of a number, the reverse process of getting the square of a number, meaning we need to think or identify a number or expression that when multiplied by itself will give us the given number or expression. Example, square root of 4x squared, that is 2x, because 2x times 2x will give us 4x squared. Now let's proceed in identifying whether a trinomial is a perfect square trinomial or not. Here, we will just be using PST as the acronym of perfect square trinomial. In doing so, we need to answer the following questions. Are two of the terms perfect square? Second, is the remaining term equal to the twice the product of the square roots of the two terms? If both answers to the questions are yes, then it is a perfect square trinomial. Otherwise, it is not. Let's have some examples. Number 1, here, the first and third term are perfect squares. Getting twice of the product of their square roots, we have. Notice that we use positive 9 instead of negative 9 because the remaining term has a positive sign. Otherwise, we will use negative 9. Now, since 18x is equal to the remaining term, we can say that a trinomial is a perfect square trinomial. For number 2, here, the first and last term are also perfect squares. Getting twice of the product of their square roots, we have. Note that we use negative 5y as the square root of 25y squared instead of positive 5y, since the remaining term has a sign of negative. We'll use 5y if otherwise. Now, since negative 20xy is not equal to the remaining term, which is negative 10xy, we can say that the trinomial is not a perfect square trinomial. After knowing how to identify when is a trinomial a perfect square trinomial or not, we can now proceed to identifying the factors of a perfect square trinomial. In factoring perfect square trinomial, we will be going to identify the binomial that when multiplied by itself, it will give us the trinomial given. That can be done by, first, identifying the square root of the two terms that are perfect squares. Second, by using sign of the remaining term of the trinomial between these roots. Finally, raising the obtained binomial to the second power. Let's have some examples. For number 1, after knowing that a trinomial is a perfect square trinomial, we identify the two terms that are perfect squares and identify their square roots. We then use the sign of the remaining term between the roots. Finally, raise the obtained binomial to the second power, and we have. For number 2, we can notice that we can reduce the given polynomial by factoring it out using common monomial factor, which is 2x. And we have the factors. We can observe that the second factor is actually a perfect square trinomial, and therefore, we need to factor it out. Get square roots of the two terms that are perfect squares, which are. So we have. Use the sign of the remaining term between the roots. Raise the obtained binomial to the second power, and we have. Since this is just the factored form of the PST, we still need to write 2x as part of the factors, and this will be our final answer. For number 3, we can notice that 3 of the terms can be grouped having a PST, and these terms are. So we have. Getting the square of a binomial form of the trinomial, we have. Copying the 16 as the first term, we have this. And still, this can be factored out using difference of two squares. We have. For number 4, let's try to group the terms. In this example, notice that if the x and the y's are grouped, we'll be lacking another term for PST. So we try to rename the remaining term, which is negative 7, into 9 minus 16. We have. From the renamed term, we can now have two PSTs. We have. Rewriting these PSTs to square of a binomial form, we get. With this, we can still factor it out using difference of two squares, giving us the final answer. For number 5, in this given, we first try to simplify each term by using distributive property. Then we have. Now, regroup the terms having two PSTs. We have. Rewriting these PSTs to square of a binomial form, we get. With this, we can still factor it out using difference of two squares, giving us the final answer. Alright, that's all for today. I hope you learned a lot about factoring polynomials involving perfect square trinomials.